All right, so we are going to see proof by contradiction today. First of all, I'll be writing the steps to success, and then we'll be trying to see an example. So, step one is about assuming the opposite. So whatever the statement is given to you to prove, you need to assume the opposite. That's the first thing. Step two is about writing the mathematical meaning of your statement. So whatever you assume in the first part of your proof, write the mathematical meaning of it. And the step three, which is about trying to contradict, so contradict the assumption. So these are the three steps. Depending on the problem, your assumption will be different, but the steps are actually three. So let's do an example. Let's go through the following ones. Example. For example, we are asked to prove by contradiction root 5 is an irrational number. So to prove that this is an irrational number. Okay, so we're assuming the opposite to start with. So step one, which is about assumption. So I'm going to assume, step one, I'm going to assume that root 5 is a rational number. Now, remember, the key part here is to understand what actually rational mean. Now, rational means that root 5 can be written as a fraction such as a over b, where a and b are integers and they are also co-prime. Co-prime means they don't have anything in common, so they don't have any common factor. So now I'll come to the step 3, where I'll try to use this relationship to contradict my assumption in step 1. So let's rewrite the statement. So that's going to be root 5 equal to a over b. And to make things nicer, we can actually square both sides to get 5 on the left side, because square root of 5 square root of 5 is just 5, equal to a squared over b squared. If we rearrange the equation now, this will give me a squared equal to 5b squared. Since b is an integer, b squared is also an integer, which means 5b squared is a multiple of 5. Now, since a squared is a multiple of 5, a must be a multiple of 5a too. And we can write this as 5n. So a is equal to 5n because the square of a is a multiple of 5. Now, let's see what would be the value of b if we assume a to be 5n. So let me just go to the new page. So we said a was equal to 5n, which means it's a multiple of 5, and our initial relationship was 5 equal to a squared over b squared from the previous page, as you can see in here. Okay, let's go back. Now we're going to replace a squared with 5n, and this will give us 5 equal to 5n squared divided by b squared. Let's rearrange things in here, and this will give us 5b squared equal to 25n squared. If I evaluate 5n to the power of 2. Okay, now let's find out b squared by dividing both sides by 5. This will give us 25n squared divided by 5, which is 5n squared. Again, we have, let me just rewrite this one clearly. So that's 5n squared. 25 divided by 5 will give you 5. So this means 5n squared is a multiple of 5. So b squared is a multiple of 5, which implies that b is also a multiple of 5 for some integers, some integer k. So that could be, for example, b equal to 5k. Okay. Finally, we initially said that a and b are co-prime, which means we assume that they don't have any common factor. Since both a and b are multiple of 5, therefore this is a contradiction to our statement. So we have a contradiction to the initial assumption. Hence, root 5 cannot be rational. So this is our final conclusion.